Hello everyone, we're going to focus on some basic trigonometry in this lesson. What we're going to look at are three of the ratios that is associated with trigonometry, which are sine of an angle, cosine of an angle, and tangent of an angle. Now, what you need to understand that the ratio which is opposite over hypotenuse is associated with sine of an angle, and adjacent over hypotenuse is associated with cosine of an angle, and opposite, the ratio opposite over adjacent is associated with tangent of an angle. Now here, would have known that I have sine x is equal to opposite over hypotenuse. X in this case represents an angle. Cos x is equal to adjacent over hypotenuse. X again represent an angle. It represents any angle in the given right angle triangle. Now these ratio is associated with right angle triangle, right? That's what they are associated with. Now, as you know about right angle triangle, that one angle is in the triangle is 90 degrees, which is denoted by this little box here. And all of my three triangles have these boxes to suggest that it is 90. Also, another property of the right angle triangle is the hypotenuse. You know that the hypotenuse is the longest side on the right angle triangle, and it is always opposite to the 90-degree angle. And opposite in this context means in front of, right? Now what we're going to look at is how do you label the triangle in terms of hypotenuse, the sides of the triangle in terms of hypotenuse, opposite, and adjacent. Now let's look at the first one. Let's say that somebody asks you to label the sides of this triangle here. Now there is no angle in this triangle that is indicated, so they didn't give us an angle in this triangle. So the only thing that we can label on this triangle is the hypotenuse, which is HYP. Now we know that the hypotenuse is always opposite to the 90 degree, as this arrow suggests. Now you cannot say that this side is opposite or this side is adjacent. Why? Because there is no working angle inside of this triangle, right? They didn't give you an angle, so you cannot say, just randomly say that this side is opposite, because you have to ask yourself, opposite to what? Or if you say that this side is adjacent, you have to say that adjacent to what? So it is basically the angle that tells you which side is opposite from which side is adjacent, and you have to understand that as a student, right? So in this triangle, there is only one true side that we can truly label without an angle, and it's the hypotenuse. You will always be able to highlight where the hypotenuse is, because you just look for where that 90 degrees is, and you know opposite to the 90 degree is the hypotenuse, right? So let's move on to this one. Here they give us an angle which is x, right? So again, we know that opposite from this 90 degree going in this direction, we would have the hypotenuse, right? So this side would be the hypotenuse. So this length here would be the hypotenuse. Now we have an angle which is x. So we know that opposite from this angle going in that direction, the side that is opposite to the angle is always opposite. So here is opposite, directly in front of angle x, opposite. Now the side that is alongside the angle, or the side that helps to make up the angle, is always the adjacent. And so this side would be the adjacent. And that's how you would label the sides of a triangle. Note though, depending on the working angle that you are given, the opposite side and the adjacent side will change from time to time, right? So in this one, we could label all three sides because we are given a working angle, and in this case, the working angle is x. So we know that opposite, if we draw a line straight from this angle to this side, that would be the opposite side. Now, alongside this angle would be this side, which means that this is the adjacent. And we know that the longest side is always called the hypotenuse, right? Let's look at this triangle over here. Now, the working angle in this case is on top here. So we know that if we draw a line from here and put an arrow on it, we get this side. So this side has to be the opposite side. So this is the opposite side, right? Now, if we draw a line from the 90-degree box going this direction, which is the longest side, we know that this side has to be the hypotenuse, right? Which only leaves us with one thing to label, which is this side, and it has to be the adjacent, since we know for a fact that these two sides are accurate, which is this side is the opposite side and this side is the hypotenuse. Then this has to be the adjacent side, right? And we know that adjacent in this context means alongside, and opposite means directly in front of, right? And that's how you would label your triangle based on what you have, right? Now, you need to understand this, because most of the time when students are given a problem, they fail to label the right angle triangle correctly, and because of that they use the wrong ratio to try to attempt the question. So understanding how to label your right angle triangle, the sides of your right angle triangle, is very key. So note again, look at the three scenarios that I have. Here, there is no working angle. So the only true side that you could tell is the hypotenuse. In the second one, you have a working angle. But note here, this side is opposite, this side is adjacent. The hypotenuse stays constant, right? It's always the longest side, right? And over here now, the angle, the working angle, is now at this position, which is different from this one. Note that this side becomes the opposite and this side becomes the adjacent. So what am I saying? You cannot tell which side is opposite or adjacent unless you are given a working angle. That's basically what I am saying. Now, you use these ratios to solve for two things. You can use the ratio to solve for a missing angle, and you can use the ratios to solve for an missing side, right? But that means you will have to give in some information about the triangle. Now, let's say we put on some measurement on this side, and we are going to look at using these ratios to solve for a missing side, right? Let's say that they say the angle of this triangle here is 30 degrees, right? It's 30 degrees. And they say to you that we do not know what this side is. So in this case, I am going to call it y, the length of this side, y. And I am going to say that the length of this side is now 4 centimeters, right? So we know that the angle, the working angle, is 30 degrees, and the side that we want to find is y, and we can put centimeter on it, is y centimeter, and we are given this information here. How would you go ahead to use one of these ratios to solve for it? Now, based on what you have, based on the information that you have, you need to label the sides of the triangle based on the information that you have. Now we know that this angle is 30, so opposite from this angle would be this side. So this side is opposite, and it would be y centimeter. We know that from this side here, this would be the hypotenuse. And that means this side would be the adjacent, right? Now we want to find the length of this side, which is y centimeter, which is the unknown you don't know. What you need to do is to look at the ratio and see which one of them is associated with the information that you have been given. You know that you have an opposite side here based on the information and an adjacent. So you have opposite, adjacent. This sine ratio has to do with opposite hypotenuse. You don't know the length of the hypotenuse. So this ratio is out. You cannot use this one. Now you look at this one. Cos x is associated with adjacent over hypotenuse. Of course you have information about the adjacent side. But do you have any information about the hypotenuse? No. So this one is out. So the one that you can use to determine the length of y is tan x, which is opposite over adjacent. Do you have information for the opposite side? Yes. Do you have information for the adjacent side? Of course. So you can write your formula to say that tan x is equal to opposite over the adjacent. Now, what is x in this case? X in this case is 30, so you say that tan 30 degrees is equal to opposite. What's the opposite length? Which is y over what? Over what? Over the adjacent. But what's the adjacent length? The adjacent length here is 4. So tan 30 is equal to y over 4. Now remember that you need to solve for y, because y is what you want to find. Right? So y is the unknown here. You want to find what y is. So therefore, you need to multiply both sides of this equation by 4 to get rid of 4 to get y by itself. So if you multiply this side by 4 and you multiply this side by 4, then this cancels out this. So y is equal to 4 times tan 30. And all you need to do is to put this on your calculator and you're finished. Which is equal to 2.3 to 1 dp. And that's how you would find the length here. So the length of y, so therefore y centimeter is equal to 2.3 centimeter. And this is correct to 1 decimal place. Right? And that's how you would do it. Right? So that's how you would use the ratio there. Now let's look at another case. Let's look at this one. So let's say you know the angle here, and they tell you that the angle in this triangle is 60 degrees. And ensure that you always have a calculator, because you cannot do trigonometry without calculator. You need one. And they tell you that this is 60 degrees. They tell you that the length of this is 5 meters right here. And they ask you to find this side, and they tell you that this side is x centimeter. No, x meter, sorry. So they want you to find this side here. Right? Now, you know in your triangle you have been given an angle which is 60 degrees. You know that you have been given the length of one side, and now you are asked to calculate the length of another side right here. Now, what are you going to do? Again, first thing, label your triangle. So, from this angle, we know that this is the hypotenuse. Now we are given this angle, so we know that if we draw a line going this direction, this is opposite to the 60 degrees. So this side is opposite to the 60 degree. Now, do we need to label this? Based on what we want to find, we don't have to label this, but let's just go ahead and label it. So this side is actually the adjacent side, right? Now we have an angle which is 60 degree. We have a side and we have a missing side that we want to calculate. Now we need to decide which one of the ratio we need to use. Again, this is opposite and hypotenuse. It seems that we're going to use the ratio opposite and hypotenuse. Which one of the angle is opposite and hypotenuse associated with? Let's check opposite and adjacent. No, we don't need this one. Let's check adjacent and hypotenuse. No, we don't need that one. So we don't need this. Opposite and hypotenuse, yes, this is the one that we need. Because opposite over hypotenuse is associated with sine of an angle. So therefore you can go ahead and write your formula to say that sine x is equal to opposite over the hypotenuse. Now what is x in this case? X in this case is 60. So write sine 60 degrees is equal to the opposite. But opposite, they are talking about the opposite length, you know. What is the opposite length? 5. So this is 5 over what? The hypotenuse, which is x in this case. They want you to calculate the length of x. So which is x. Alright. So now you need to solve for x. What you can do to solve for x is to multiply both sides by x. So if I multiply this side by x and I multiply this side by x, then x cancel out x. Follow me? I left back with x times sine 60 is equal to 5. Now I want x by itself. Now I am multiplying this x by sine 60. So I'm going to divide both sides by sine 60. So I divide this side by sine 60. And then I divide this side by sine 60. Now sine 60 will cancel out sine 60. That left me back with x on this side, which is equal to 5 divided by sine 60. Now all you need to do is to put this on your calculator, and I am going to show you how you put that on your calculator. So here on your calculator you will see a little button that have SIN, which means sine. Right? So what you're going to do, you're going to put 5, right? Which is 5. This means a fraction here. So you can press this bar here and you get the fraction. And you need to put sine 60. So you press sine and then you write the 60 degrees, 60. And you put a little bracket to close off. All you need to do is to press equal. It will give you insert form. You press this button here, which is SD. You press it and you get the decimal form. When you press it, your answer is approximately 5.77. So we're going to round off that to one decimal place. So our final answer would be 5.8 to 1 dp. Right? And that's how you use your calculator. So your answer is, so x is equal to 5.8 meter, correct to 1 decimal place. Right? So that's how you would use it. So I hope that people are now getting more comfortable in applying the trig ratio to find the length of a marked side, right? Now let's look at this triangle. Let me just use this one, since that one is already a bit far. So let's see that here you have an angle, and the angle that you have been given is 25 degrees. Remember that my drawing is not drawn to scale. So this is 25 degrees, right? And they tell you that the length of this side is 13 centimeter, right? And they want you to find the length of this side, and they say, okay, the length of this side is a centimeter. Calculate the value of a. So they want you to find the value of a there. So that's what you have been given. Now again, it's always best to label a triangle. So let's label the triangle based on the information that we have. So we know that this side is actually the hypotenuse. Right? We know that this side in front of this angle is this side, which means that this side is opposite. This side helps to make up this angle, which means that it is alongside the angle. So this side over here has to be the adjacent. Now we know that we have information for the adjacent and we have information for the hypotenuse. So the ratio adjacent over hypotenuse is associated with cos of an angle, if you notice here. So we wouldn't use this one because this one is talking, the sine of an angle here, ratio is talking about opposite over hypotenuse. Do we have the opposite? No. We don't have any measurement here. So we cannot use this one. And because we can't use the opposite here, if you look at the tangent ratio, you know that it has something to do with the opposite. So we cannot use this one either. So the only one that we are left back with is cos of an angle. So this ratio can be used. So you write your formula. So you see cos x is equal to adjacent over hypotenuse. Right? Now, what is x? X in this case is 25 degrees. So cos 25 degrees is equal to the adjacent length, and the adjacent length in this case is a. We don't know it. All over the hypotenuse length, which is 13. Right? So now we are solving for a. Right? So all you need to do is to multiply both sides of the equation by 13, because you are dividing by 13 and we want to get rid of the 13 and get a by itself. We just multiply both sides by 13, right? So if you multiply this side by 13 and then you multiply this side by 13 here, then 13 will cancel out 13. So on this side you're left back with a, which is equal to 13 times cos 25 degrees. All you need to do is to just put this on your calculator and you find the value of a. So let me show you again. So here I have my calculator. So all you need to do is to put 13, which is 13 multiplied by, you look for COS on the calculator, which is now this. So you press cos and the angle is 25 degrees, so this is 25. Put a bracket and press equal. So your answer is approximately 11.78. Well, if you want to round this off to one decimal place, you look at the second digit, which is 8. Because it is greater than 5, you increase the previous digit by 1 and forget about the rest. So this would be 11.8 to one decimal place. So a here would equal to 11.8 correct to 1 dp. And that's how you would find the answer. So again, our final answer is a is equal to 11.8, and remember your unit, which is centimeter, and you put in bracket correct to 1 dp to indicate that you have rounded off to one decimal place. And that's it. Thank you for watching. In the next video we will look at how you use these ratios to find the missing angle.